Hi, welcome back to the channel. So in this video we are going to see the rules for finding complementary functions. Okay, so in the problems of Euler equations are in complementary functions. So what are the rules? The first rule is, if different real roots are there, let m is equals to alpha comma b the roots of auxiliary equation. So the complementary function yc is equals to c1 e power alpha x plus c2 e power beta x. This is a complementary function for the different real roots. For example, if the function is d square minus 1 into y equal to 0, the auxiliary equation for this is m square minus 1 equals to 0. If you take m square m from this, m equal to plus or minus 1. So m equal to plus or minus 1 indicates alpha is plus 1, beta is minus 1. So substitute the alpha and beta value in this. So c1 multiplied by e power alpha is 1x plus c2 e power beta value is minus x. So in this format it is going to be if the roots are real roots. Okay, so example 2, you can take d square minus 4y equal to 0, auxiliary equation m square minus 4 equal to 0, m square equal to 4, m is equal to plus or minus 2. So here alpha is 2 and beta is minus 2 in the same similar fashion. Okay, suppose the rule 2, if the roots are complex roots, different complex roots at that time. So let m equals to alpha plus j beta, alpha minus j beta are the roots of auxiliary equation. Complementary function yc is equals to e power alpha x, e power alpha x into c1 into cos beta x plus c2 sin beta x will come. Okay, suppose example d square plus 1 y equals to 0. Auxiliary equation is m square plus 1 equals to 0. If you push 1 here, m square equal to minus 1. So the roots of this m are plus or minus j. The meaning of this is, that is plus j minus j. Plus j means 0 plus j, minus means 0 minus j. Standard format alpha plus j beta, alpha minus j beta. In this, alpha value in both the cases is 0. And what is the value of beta in both the cases? So here 1, here also it is 1. You can observe here minus minus, so beta is 1. So the complementary function yc equal to e power 0x, so 0 alpha is 0 into c1 cos beta, beta value is 1, and here also 1. Okay, so this is when the roots are complex. This is the roots when are real roots. Okay, real roots, this is a complementary function, and this is a complex root, this is a complementary function. Okay, so suppose how to find out the particular integral pi. Case 1, function f of d into y is equals to e power ax is particular integral. You take this y here, so this e power ax divided by f of d. So put d equals to a equals to 1. Suppose in case the denominator, if this value is 0 at that time, you should multiply the numerator by x, and here you can take the differentiation of denominator. So particular integral for this case becomes x into e power ax divided by f dash of a. Okay, so this is the case number 1. Similarly, go for the case number 2, f of d square. So in this case it is f of d, so it is f of d square y is equals to sin ax or cos ax. So at that time, what is yp? Yp is equals to particular integral equal to sin ax divided by f of d square. Okay, so d square equal to minus a square, or d square equal to minus 1. So you can yp is equals to sin ax divided by f of minus a square. This is the case number 2 if it is a sine format or cos. Next, if it is a x power n format, particular integral yp is equals to x power n divided by f of d. If it is a polynomial function. If it is a sine and cos function, it is like this. If it is a e power ax, it is like this. So e power ax, sine or cos ax, polynomial. Okay, the particular integral for this. So these particular integrals, case 1, case 2 and case 3, and followed by these rules for complementary function, different real roots and different complex roots will be used for solving the problems like finding the extremal of the functions in the Euler equations part. So we'll see these problems in the next sessions. Thank you. Stay tuned to this channel for the latest updates. Click on the bell icon, select all notifications so that you will get the immediate notifications once you solve the problem. Thank you.